Okay, so this is a difficult question. So let's just read it. So where E is bounded by the paraboloid this and the plane this. So let's quickly give this a rough sketch. And it's telling you that you have a paraboloid, and the paraboloid is going to look like this. That's a horrible paraboloid. Yes. And you should always know that whatever the paraboloid is equal to, so in this instance it's equal to x, that is what it's parallel to. So this is x, this is y, this is z. And we also know that x is equal to 4, so the paraboloid is being cut off by this plane. So that's a plane. I do it as a line, but it's a plane. So that's what it is. So now we have to figure out what E is. Now, this is my second attempt recording this video. The first attempt, I said, well, let's go x, y, z. And I tried to solve it like this, and did whatever. This is way too hard. There's probably a way to do it, but it's too hard for me. I'm a simple man. I need simple ways to do it. So basically, whenever you've gotten something like this, and it's triple integrals for volume, and you've got a circle involved, you have to use cylindrical coordinates. Alright? So let's just write out this. So E, x, dv. You need to know that another way you could write this is x, and instead of dv, you could write dx, dA, right? People, hey Jay, this Saturday what happened to say you don't need to work this Saturday? Thanks. Oh, I didn't have to work. Alright, go away. How do I make that go away? Alright. You're distracting me from the maths. What was I saying? X, dx, dA. Alright, and we know that dA, so let's just rewrite this one more time. We know that dA is dx. We know that dA equals r d theta. So this could be, idiot, that's an x. Whoa, that's an x. D theta, dx, dx. Yeah, sorry, dx, dr, d theta. There should be an r there. What am I doing? Alright, you get it? Because this is how you figure out the volume of something. You find the area and you times it by the height, and that's all you're doing here. Okay, with that being said, let us write what E is equal to. Well, let me stay here. So E is equal to, and let's do this in regards to r, theta, and x. Whoops. So what is r equal to? So r is the radius of the circle. So what is the radius at the point of x equals 4? Well, we just sub in our values. We just have to make this equal that. So you'd go 4 equals 4y squared plus 4z squared. You realize you can divide both sides by 4, so you get 1 equals y squared plus 4z squared, and this tells you that the radius is just equal to 1. So the radius is going to be from 0, less than or equal to r, go away, less than or equal to 1. And then your theta is just a whole circle, so that's easy. It's just 2 pi. And then your x is also not that bad, because you know that your x is going to be from x equals 4 to the paraboloid, to the paraboloid, to the paraboloid. So 4 is your greatest value, and the paraboloid is your smallest value. So it's going to be 4y squared plus 4z squared is less than or equal to x is less than or equal 2, 4. Now, you should also realize something. You should realize that you can write this, so let's take this. This could be rewritten as y plus z squared, right? And we know that this equals r squared, right? So another way you could write 4y squared plus 4z squared is 4r squared, right? So you could rub this out and rewrite it as 4r squared. And you've just made your life a whole lot easier. Alright, let's get rid of this. Alright. Now let's write our equation out. So x is going to be the first thing we do, and theta is always the last thing we do. So let's put theta here. So 2 to 0, 2 pi to 0, r is 1 to 0, and x is 4r squared to 4. Oh, idiot. So this is where you're going to screw things up. You have to realize that the bigger number goes on top, and your bigger number is 4. Your smaller number is 4r squared. Yes. Then you've got x. Don't forget your r. Actually, don't worry about the r first. dx r dr d theta. Alright, after all that work, that's the hard part. Now we do the equation. Let's move up a bit more. So now it's just really going through the motions. So now we integrate with respect to x, and we get x squared on 2 between 4 and 4r squared, r dr d theta. This gives us 2 pi 0, 1, 0, 16 on 2 minus 16 r4 on 2. Yes, r dr d theta. Then we go up here. Two pi 0, 1, 0. So this is now 8 minus 8r4 r dr d theta. So the next step we have to do is integrate this with respect to r. Let's change color. So we're going to get 2 pi 0, 8r minus 8r to the 5 on 5. Oh, idiot. What have you forgotten to do? Before you can integrate with respect to r, you need to put this r into it. ar squared minus ar5 dr d theta. Idiot. Then we're going to go 2 pi 0 a to the r3. Is this correct? No, what have you done? That should be AR. Because that becomes AR. This becomes 8R. This becomes 8R5. Alright. Then you go 8R squared on 2 minus 8R6 on 6 between 1 and 0 d theta. Ah, you're an idiot. Alright. Then you go 2 pi 0 4r squared minus 4r6 on 3 1 0 d theta. So this becomes 4 minus 4 on 3. Don't worry about putting the 0 in. 2 theta 0 d theta. Oh man, this thing forever. This becomes 12 on 3 minus 4 on 3 d theta, which becomes 8 on 3. Does that look right? D. And then you have to integrate with regards to theta, and that's always fun because you just add theta, and you're doing it between 2 pi and 0. You don't have to worry about subbing in that 0, you just have to sub in the 2 pi. So you're going to get 8 2 pi on 3, which equals 16 pi on 3. And that, let us hope, is the answer. 16 pi on 3. You done it. Ugh.